Okay, hi. This lecture's on has the first lecture set of lectures 1.1.2.1.3 was about adding vectors in Rn and multiplying them by numbers and taking linear combinations of them, and it culminated in the concept of the span of vectors in Rn in a particular n. We looked at the different possibilities for the span of vectors in R2 and in R3, and that's how it culminated. That's very important. This is somewhat different and complementary. Now we're going to talk about the length of vectors and their dot products. So we have a new operation. This is not part of the first chapter, called the dot product. Okay, so we defined let's say U and V are in Rn. They have n elements each. Then U dot V is equal to the sum of the products of the corresponding elements. Okay, so for example, if I have 1, 2, 1 dotted with 0, -1, -4, I get -6. So this goes from, this is a function that takes two vectors to a number. All right, then we define length to be the square root of dot product of U with itself. This keeps the idea of length to be consistent with our representation in the plane. For example, in R2, for example, it also works for any Rn. If I have, for example, say here's U, well then the length would just be, this would be U2, right, and U1. And then the length of U is just the dot product of U with itself, U1 times U1, so U2, U2, and I take the square root of that, so that gives me this length. So this vector is U, but this length is the size of the vector U. All right, we have the following, so we can, I guess, call this, we'll motivate it in a second, but we'll say that, well, it's not really a definition. We can just say it's a property is that U dot V, U and V in Rn, U dot V is equal to U V cos theta, where okay, so for example, because U dot V is quick to compute, as is the length of U and length of V, this gives us a way to find the angle between two vectors. Also, if we know the angle between two vectors, it gives us, well, gives us any of these other things. So we can use this property. Suppose there's some example. So for one thing, you can see if, say they're right angles, like say we have, suppose we have R2, and I have this one and this one. So say we have right angles here. So say I have, let's see, -2, 2, dotted with, let's say this one is -3, -3. This is 0, right? So u dot v is 0. Well, the lengths aren't 0. Of course, the lengths are something. So this implies cos theta has to be 0. And because theta is between 0 and pi, this implies theta equals 90 degrees. Okay? All right. Okay, very good. So this identity or property comes from the law of cosines in planar geometry. So let's just see that. So the identity, so this comes from law of cosines. Now, imagine R2 or even R3 if you want, and I have, say, because I think we'll agree it's probably a little hard to think about R4, but if you like, think about these extending into 4 dimensions too, and are also maybe some angle associated with that. So let's see, if that's V and that's U, what's this? It must be U minus V, right? Well, law of cosines. So law of cosines says from high school, it says this length squared, the one opposite the angle, is equal to U squared plus V squared minus 2UV cosine theta. Okay? You might remember. Now, if these are at right angles to each other, U and V are at right angles to each other, this term's 0. And we just get Pythagorean theorem, right? So this includes Pythagoras. Okay. But in general, when it's not a right angle, we have this correction. I won't prove this law of cosines. If you like, look it up. But from here, we can easily get to our identity. So let's see how much time we have. Yeah, I suppose it's worth it. So so let's proceed as follows. So if I accept this identity, so by the law of cosines, right? Let's actually, we'll get what we want. We have U V cos theta is equal to, I will subtract and divide by 2. So I have 1/2 U minus V squared minus U squared minus V squared. Right, just subtract. And now this part in here I can show is, so now what is this? U minus V squared. This is just equal to U minus V dotted with itself, right? So this is U1 minus V1. That's the first element up here. Dotted with itself, squared. Now plus, dot, 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 all the way. Oh, well, we're only going to do it for R2. Well, let's do it for Rn, if you accept law of cosines for more than Rn. And I have all the way plus un minus vn squared. But now, if I multiply these out, this is equal to u1 squared plus u2 squared and now plus, or let's say minus 2 u1 v1 plus dot 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 plus un vn, and now plus v1 squared plus v2 squared plus dot 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 vn squared. So this and this you recognize, and this you recognize, right? So what recognize, take a second to see what those are. And you see the first one is the length of u squared. The second one is the length of v squared. And this thing in the middle here is u dot v, right? So we have, so continuing then, I want to make sure we stay, you can see that. So this is equal to, so let's just recap it here, u minus v squared equals the length of u minus v squared is equal to the length of u squared minus 2 u dot v plus the length of v squared. Okay, so now if I bring that in here, I get this subtraction, right? I get some subtraction, and let's see. Let me see here. Why is it minus? Oh, yeah. Okay. Right. Look, when I divided here, when I took the law of cosines here, length of u. Okay, what I did was I subtracted these and then said I divided by 2. Okay, what I really should have done, if I divide by minus 2 to get this, right? I need to divide by minus 2. So it's 1/2 this. This, right? It's 1/2 this. So let's see, I made a little sign mistake here. So I subtract these here, and then I divide by the minus of this, right? So these are subtracted, divide by minus. So this should be minus 1/2 here. Yes, so this should be minus 1/2 here, right? Okay, now we're back on track. So we have, this is equal to this, right? And so then, by law of sines, we have u v cos theta equals minus 1/2. I have this, which clearly cancels with the u squared and the v squared here. These two terms do. So all I'm left with is minus 2. This should be minus again. What the hell am I doing? Minus 2 u dot v, which equals u dot v. Okay.